order of a reaction is the sum of the powers of the concentration terms that appear in the rate law. For a general reaction, AA plus BB giving CC plus DD, the rate law is R equal to K into A power X into B power Y. Here the power of A in the equation is X. So order with respect to A is X. Power of B in the equation is Y. So order of reaction with respect to B is Y. The overall order of the reaction is equal to X plus Y. That is, X is the power of A and Y is the power of B. The sum of the powers X plus Y gives you the order of the reaction. So from this equation you have to take note that X and Y that appear in the rate law may or may not be equal to A and B that is coming in the given equation. Some examples: rate law equal to R equal to K into CH3CHO power 3 by 2. Here the power of the concentration term is 3 by 2. So order of the reaction is 3 by 2. R equal to K into H2 into I2. This reaction is first order with respect to hydrogen, first order with respect to iodine. So the overall order of the reaction is 1 plus 1, that is equal to 2. R equal to K into NO power 2 into Cl2. The power of NO is 2, power of Cl2 is 1. So the order of the reaction is 3. R is equal to K into NH3 power 0 or equal to K. Order of the reaction is 0. R is equal to K into O3 power 2, O2 power minus 1. Order with respect to O3 is 2 and with respect to O2 is minus 1. Overall order of the reaction will be equal to 2 plus minus 1, that is equal to 1, or this is a first order reaction. R is equal to K into A power half, B power 0, C power 5 by 2. Order with respect to A is 1 by 2, with respect to B is 0, with respect to C is 5 by 2. Overall order of the reaction will be half plus 0 plus 5 by 2, that is equal to 3, or this is a third order reaction. We have two different types of reactions. One is elementary reactions, which are chemical reactions that take place in a single step. For example, hydrogen plus iodine gives hydrogen iodide. This reaction takes place in one step. And for these elementary reactions, rate law can be written using law of mass action by use or simply looking at the given equation. So here the rate law will be R equal to K into H2 power 1 into I2 power 1. The second type is complex reactions. These are reactions which take place in more than one step. The sequence of elementary steps that occur during the reaction is called the mechanism of the reaction. The slowest step in the reaction is called as the rate determining step. So rate determining step is the slowest step that comes in a complex reaction. The overall rate law is written using the rate determining step. As an example, 3A plus 2B gives C. Consider the different steps that comes during this complex reaction. Step 1, A plus B gives 2A plus B gives P. This is a fast process. Second step, A plus B gives Q. So this is a slow process. Third step, P plus Q gives C, which again is a fast step. If you add these reactions, you will be getting 3A plus 2b giving 2c. Here the second step is the slow step, and this is the rate determining step. And using this step only, we have to write the rate law. Here there are only two reactants, A and B, one molecule each. So the rate law will be R is equal to K into A power 1 into B power 1. Even though there are 3 A molecules and 2 B molecules coming in the equation, power of A is 1 and power of B is 1, and the order of this reaction will be equal to 1 plus 1, that is equal to 2. So this type of reactions which take place in a sequence of steps is called as the complex reaction, and the slowest step in a complex reaction is called as the rate determining step. The characteristics of order. Order is an experimental property. That means we cannot find out what is the order of the reaction just by looking at the equation. As far as elementary reactions are concerned, we can find out the order from the given equation. But for complex reactions, we cannot find out the order. It is determined only by conducting an experiment. Order may be a whole number, zero, fraction, or even it can be negative. It cannot be usually obtained from the balanced equation. It does not reveal about the reaction mechanism. It is applicable to simple or elementary as well as for complex reactions. Molecularity of a reaction. Molecularity of a reaction is the number of species. Species means atoms, ions, or molecules. So it is the number of species that take part in the chemical reaction by colliding simultaneously. Chemical reaction takes place by collision between the molecules. അപ്പോൾ ഒരു chemical reactionൽ simultaneous ആയിട്ട് collide ചെയ്യുന്ന atoms, ions or molecules number is called as the molecularity of the reaction. For example, ammonium nitrite on heating gives nitrogen plus 2 molecules of water. Here molecularity of the reaction is 1 because only ammonium nitrate is taking part. So the reaction is a unimolecular reaction, or molecularity of the reaction is 1. Another example, hydrogen combines with iodine forming hydrogen iodide. Here two molecules are colliding. One is hydrogen molecule, another is iodine. So molecularity is equal to 2, or we call this is a bimolecular reaction. 2NO plus O2 gives 2NO2. Here totally 2 molecules of nitric oxide and 1 molecule of oxygen is taking part. So molecularity is 3, or we call as a trimolecular reaction. H2 plus half O2 gives H2O. You may think that the molecularity is 1.5. See, molecularity can never be a fraction. So this entire equation we have to multiply by 2. So when you multiply it by 2, we will get the number as equal to 3, or this is a trimolecular reaction. 3A plus 2B gives 3C. Here there are 5 molecules taking part. So we may lead to the conclusion that molecularity of the reaction is 5. But molecularity is not 5. Molecularity of a reaction is always a small number. Molecularity of higher order is not at all possible. It is because the chance of many molecules colliding simultaneously is less probable. Molecules തന്നെ വളരെ ചെറിയ സ്പീഷീസ് ആണ്. അപ്പോൾ ഒരേ സമയത്ത് വളരെ കൂടുതൽ മോളിക്യൂളുകൾ ഒന്നിച്ച് കൊളൈഡ് ചെയ്യുക അസാധ്യമാണ്. അതുകൊണ്ട് തന്നെ മോളിക്യുലാരിറ്റി എപ്പോഴും ഒരു ചെറിയ നമ്പർ ആയിരിക്കും. സാധാരണഗതിയിൽ 2 മോളിക്യൂൾ, ഹിയർ 2 molecules are colliding simultaneously. Here 3 molecules are colliding simultaneously. Here 4 molecules are colliding simultaneously. ഇത് തന്നെ ഈ 4 molecules collision തന്നെ വളരെ rare ആണ്. അപ്പോൾ കൂടുതൽ probable ആയിട്ടുള്ളത് 2 3 ഒക്കെയാണ്. So molecularity is always a small whole number. It is having value usually 1, 2 and 3. Not more than 3. Molecularity more than 3 is very rare. So why higher molecularity and higher order reactions are less probable? It is because simultaneous collision between large or many number of molecules are not at all possible. So if you consider the reaction 3A plus 2B giving C, this reaction is taking place in number of steps. Step 1, 2A plus B is equal to P. Fast reaction. Here there are 3 molecules taking part. So it is a trimolecular reaction. Step 2, A plus B gives Q. Here 2 molecules are participating. It is a bimolecular reaction. Step 3, P plus Q gives C. This P and Q that are taking part. So it is a bimolecular reaction. So if you add these 3, you will be getting the final reaction. So in a complex reaction, the overall molecularity is not there. Each step of the complex reaction will have its own molecularity. Molecularity is always a small whole number. It cannot be 0 or a fraction. It is the theoretical concept. Consider order. Order is a experimental concept, while molecularity is only a theoretical concept. For complex reactions, molecularity is not at all significant, and each step in the complex reaction will have a molecularity. Difference between order and molecularity. The first point always will be writing the definition of the concerned things. Order is the sum of the powers of the concentration terms in the rate equation, while molecularity is the total number of reacting species which brings the chemical change. Second difference is order may be a whole number, 0 or a fraction, but molecularity is always a whole number less than 4. Only 3 values are possible for molecularity usually, 1, 2 and 3. Order is experimentally determined, while molecularity is only a theoretical concept. We can give order for elementary reaction as well as for complex reactions, but molecularity is meaningful only for elementary reactions. Complex reactions will not have a molecularity. In complex reactions, I told you, there will be more than 2 steps, and each step will be having its molecularity. Order does not reveal anything about the mechanism of the reaction, while molecularity reveals the basic facts about the mechanism.